Okay, thank you so much. Great to be here. So I'm Stefano, and Luca here. If you want to come and show the guitar, so we are from Mind Music Labs. We are actually sitting downstairs, a couple of floors. And pardon me if I talk about software at Hardware Talk. And how do I do it's a presentation here, right? Present. Yeah. Yes. Great. So what we have is this guitar that now 1 minute is too short to show it live, but if you play the guitar, you can try it later. So just a very quick video about what the guitar can do. It's as an integrated sound engine.
This is the demo video for the first prototype.
And so it produces sound from the wooden body. And we control sound with sensors. Okay. But the guitar was pretty much an excuse because we like to talk about this physical computing. So we do use some kind of special sensors for capturing the sound of the strings with kind of special pickups. But I guess that not many of you are interested in that. So what might be interesting to anyone is that musical instruments, they pose some kind of requirements when you want to do interactive devices, like physical computing. So other examples of these kind of devices are like stuff that does augmented virtual reality, tangible interfaces. So basically, there are just tiny little things that they have electronic inside, but you feel like they are magic. So the electronics, the computing disappear. And how you do that? And it's mostly you have to design the thing so that you bridge, you eliminate all these gaps between the perception and the action. So it comes down to just 3 factors. It's time, scale, and psychology. Yes, the first one, the last one, yes, it's really psychology. Or maybe better talk about psychophysics. And actually, Luca here is our expert in that. He has a PhD in psychophysics and audio tactile perception. And the critical thing is that if you compare to how sensors are used like in a nuclear plant, in a normal control loop, you have a closed loop interaction from sensors, computing, and actuators. And for these devices, you have the human in the middle. So what is important is not to have sensors that are precise, but they have to feel precise. So at the end, it's just a human judgment. And about time, you need to achieve these good results. And mostly it comes to 2 factors. The first one, you need accurate timing. So if you press one button, one pressure sensor on the guitar, and if you have to wait 10 seconds and then the sound arrives, you break the magic. So you need to treat sensors and sample the signals like you would do with proper signal processing techniques. And for the rest, it's really a lot about latency, which is the most critical factors. And talking about latency, it depends on your target product. You may have different requirements on your target number of the latency that you have to achieve. For example, for pro audio processing, we have to stay below 3 milliseconds round trip. And if you just consider the time from action to sound generation can be 10 milliseconds, If you do not a pro, you buy consumer product, this you can stay 30 milliseconds, or if you just need the normal stuff like user interface, you can go up to 100. And so these are what you have to achieve, and then you have your constraints. So I don't tell you to do everything bare metal, because a lot of stuff, especially if you want to communicate with other computers, you need to use more higher level stuff, computing stuff. But the important thing is know where the latencies come in your chain. And this is a table, a pretty famous table, these latency numbers, every programmer should know. And just be careful that usually those are average latency times, but what are important are the worst case. So there's just be careful to take the worst situation into account. And about scale means that you want a natural linear feeling of the sensor. So you want to map the sensor, let's say, from 0 to 100 in a scale that is perceptually meaningful, so that the pressure fits really. How you do that? You don't do it in an engineering way. You let some guy like Luca to tune the parameters, so you don't need to have any compile time constants. Because if he has to wait while you compile, you flash the board, and he tries again, then he's not able to tell which one is good. So every parameter has to be tunable in real time. And that's pretty much word the secret. Thank you.